The rock cycle explained.
The rock cycle is a fascinating geological process that showcases the continuous transformation of rocks through various stages. It's like a perpetual story where rocks change over time, shaping the Earth's crust in a very dynamic way. I'm going to try and break this down into 5 manageable stages: formation, weathering and erosion, sedimentation and compaction, heat and pressure, and melting and cooling. The inception of the rock cycle begins with the creation of rocks through 2 distinct processes. Igneous rocks take shape when molten lava, often stemming from volcanic activity, cools and then solidifies. This process can occur either beneath the Earth's surface, where lava is referred to as magma, forming intrusive rocks like granite, or on the surface, resulting in extrusive rocks like basalt as an extension of lava. Sedimentary rocks, on the other hand, emerge from the accumulation and then compression of sediments over extended periods of time. These sediments, which include fragments of other rocks, minerals, and even organic materials, gradually form layers that undergo compaction and then cementation, ultimately yielding a diverse array of sedimentary rocks such as sandstone, shale, or limestone. This initial phase sets the underlying foundation for the rock cycle, introducing the primary rock types that will undergo subsequent transformations. Once rocks have taken place in their geological landscape, they'll encounter the transformative forces of weathering and erosion. Weathering involves the gradual breakdown of rocks into smaller particles through a combination of physical, chemical, and even biological processes. Physical weathering includes the effects of temperature changes, freeze-thaw cycles, and abrasion, while chemical weathering involves reactions with water, acids, or gases that alter the mineral composition, whereas biological weathering results from the activities of living organisms, such as plant roots breaking apart rocks. As these rocks undergo weathering, the resulting particles face the next chapter in their journey through erosion. Elements like wind, water, ice, and gravity will transport these weathered particles to new locations. Water, for instance, can carry away smaller particles downstream, contributing to the formation of riverbeds and deltas, whereas wind can transport lighter particles over longer distances, shaping landscapes in deserts or coastal areas. Erosion acts as a natural transportation system, rearranging rock particles and preparing them for the subsequent stages of the rock cycle. As these transported particles from weathering and erosion find their way to new locations, the next phase of the rock cycle unfolds with sedimentation and compaction. These loose particles settle and then accumulate, forming layers of sediment. These sediments can vary widely, of course, comprising of a mix of minerals, rock fragments, and organic matter carried by wind, water, or ice. Over time, the increasing layers of sediment experience compaction. The weight of overlying sediments exerts enormous pressure on the layers below, squeezing the loose particles together. It is this compression that removes air and water from the spaces in between the particles, transforming the sediment into solid rock. The cementation process further contributes to this solidification as minerals in the water fill the gaps, creating a cohesive structure. This phase results in the formation of sedimentary rocks, each layer preserving a snapshot of the environmental conditions and life forms at the time of its deposition. Sandstone, shale, and limestone are examples of sedimentary rocks, reflecting the diverse origins of their constituent sediments. It's this intricate dance of sedimentation and then compaction that marks a crucial step in this rock cycle, showcasing nature's ability to create layers of history within the Earth's crust itself. As this geological saga unfolds, some rocks, as a result of the enormous pressures being exerted on top of them, venture deeper beneath the Earth's surface, where they encounter the transformative forces of heat and pressure that we find closer to the center of the planet. This marks the metamorphic stage of the rock cycle, a process that shapes rocks into new forms without melting them entirely. The immense pressure exerted by overlying rocks and high temperatures prevailing in the Earth's interior induce changes in the mineral composition and the structure of the rocks themselves. Existing minerals may recrystallize or undergo chemical reactions, leading to the formation of entirely new minerals. This metamorphic transformation gives rise to a diverse range of rocks with unique textures and characteristics. Examples of metamorphic rocks include things like marble, derived from the metamorphism of limestone and schist, formed through the alteration of shale. The intricate dance that's taking place as a result of the heat and pressure beneath the Earth's surface creates a metamorphic tapestry, showcasing nature's ability to reshape rocks into entirely new expressions. This stage in the rock cycle demonstrates the dynamic nature of Earth's crust, where rocks undergo profound changes whilst remaining solid. Now for the grand finale of the rock cycle, where some rocks embark on a journey of transformation through melting and cooling. This pivotal stage occurs when rocks experience extreme heat, causing them to reach a molten state. The sources of this heat can vary, ranging from volcanic activity to deep-seated processes within the Earth. Once in a molten form, the rock undergoes a remarkable shift. As the molten rock rises towards the Earth's surface, it begins to cool. This cooling process is crucial as it determines the texture and composition of the resulting igneous rocks. Rapid cooling, for example, often near the surface, gives rise to fine-grained rocks like basalt, while slower cooling, typically deeper within the earth, produces coarse-grained rocks such as granite. The solidification of molten rock marks the culmination of the rock cycle as it completes this cycle by forming new igneous rocks. These rocks can later become exposed to the Earth's surface, setting the stage for the beginning of the cycle once again. It's a captivating finale, showcasing the dynamic and cyclical nature of the Earth's crust, where rocks continuously undergo processes of transformation, ensuring a perpetual geological ballet.